time to start looking at related rates with word problems. We've done enough of just doing the related rates. We need to actually be able to apply them and use them in word problems. So this is what we're going to be doing. We need to first identify an equation, do implicit differentiation, find out what we're missing, and then substitute in what we know. So let's get right into it, do some examples. Okay, air is being pumped into a spherical balloon at a rate of 4.5 inches cubed per minute. Find the rate of change of the radius. Well, we're talking right here, we want to look here, this is a volume, so we should be looking at the volume of a sphere. Volume of a sphere is 4/3 pi r cubed. First thing to do, that's write the equation. Next thing is to do implicit differentiation. So with respect to time, dv dt is going to equal, when we do this, we're going to multiply by 3 and have r squared left, so I'll have 4 pi, that's a number that just stays up front, r squared dr dt. Has to be dr dt because we're doing it with respect to time. Now, we look at what do we actually know. Well, in this equation, we need a dv dt, that's an unknown. We have an r, and we have a dr dt. So which of those do we know and which do we not know? Well, dv dt, that's how much the volume is changing. Well, there's volume, and that's how much it changes. So 4.5 for our volume, 4.5. The radius, we want to know when the radius is 2 inches. So, 2 inches. dr dt, how much is the radius changing? That's what we don't know. That's what we got to solve for. So, now we can plug everything in that we do know. We have dv dt is 4.5. Everything else stays the same. Pi, r is 2, so 2 squared, dr dt. Simplify that, we're going to end up with 4.5 divided by 16 pi is equal to dr dt. And that's fine, that can stay as your answer. I would like the unit though, 4.5 over 16 pi. This is how the radius is changing. So radius over time, the radius is in inches, and time is in minutes in this one. So inches per minute for that one. Alright, let's look at another one. In the second one, we have the side of a square increasing, and we're looking here at area. So, what I'm saying is, area equal to what is the area for a square is just area equals s squared. So, the derivative, dA over dt, will equal 2s ds dt. And again, we want to then look, based on the problem, what is it that we know? Well, we know dA dt is equal to, we don't know yet. The sides are 15 feet long. That's what s is. S is 15. We also need to look at ds dt. So we want to know how fast is the area changing. So dA dt is what we're looking for. So ds dt, the side of a square. Well, it says right here it's increasing at 10 feet per minute. So that means that must be 10 right there. So now we can plug in what we don't know. We want to find dA dt. We don't know it yet. 2 times the side is 15, and ds dt is 10. So we're just going to do that multiplication. That means that dA dt will equal 300, and again, this is dA dt. So area would be in feet squared, because we're talking first in feet, and then time is in minutes. So 300 feet squared per minute. Now, of course, that means that we need to get a little bit more complicated. These problems are going to end up with 2 variables in them, and they are much more difficult. We're going to tackle that in our next video, the ones that have 2 variables in